So if you're wanting explanations or clarifications on CFA 2.1, I'm going to go through and show how all those problems are worked out so that you can see what mistakes you made. So first of all, for numbers 1 through 6, right, we're using this graph over here to the left. So when it's asking for the x-intercept, we are wanting to know where this touches the x-axis. So our horizontal axis is our x-axis, so this graph crosses the x-axis at 4. Our y-axis is our vertical axis. So when it's asking for the y-intercept, we're wanting to know where we cross the y-axis. So that crosses up here, so this is going to be 6. The next thing it asks for is the maximum. The maximum of a graph is the highest you can go and still be on the graph, right? So if I'm going up here, I can go this high. If I go any higher, I'm above the graph. I'm no longer touching the graph. So this is as high as I can go and still be touching the graph. And that touches on the y-axis at 6. The maximum and minimum should always be where we touch on the y-axis, on the vertical axis. So now I'm going to repeat and I'm going to go as low as I can go, right? So this is as low as I can go and still be touching the graph. If I go any lower, I'm now completely below the graph. So this is as low as I can go. And if I come across, that touches my y-axis at 9. So that's my minimum. The interval the function is increasing. So I think we're doing a fine job of identifying that this is where this function is increasing. The problem is that we're not naming it correctly. We always name the function where it's increasing by the x values. So we need to chop this off here and chop it off here, right? So I'm holding my ruler of where does this start. This starts at 8 and it increases until I get to -3, right? I'm going by where it touches on my x-axis. So my decreasing portion, which is over here, again, I have to go by my x-axis. So I'm decreasing at 2, and I'm continuing to decrease until 7, right? I'm bringing this line down here, this line up here, and it's from 2 to 7. Our next chunk is asking us to plug values into a function, right? So for 7, 8, and 9, we're evaluating this function when I plug in -2, right? So for number 7, I need to say 3 minus 4 times -2. Now, some of you did this by hand, but you missed your double negative, right? 4 times -2 is -8. So this is really 3 minus -8, which would be 11. Or you can just type that all in your calculator in one big swoop. Okay, then we're plugging in 0. 3 minus 4 times 0, which will give us 3. And then we're saying 3 minus 4 times 3. So 3 minus 12, which will give us -9. Our next set, we need to determine if each of the following relations are functions. So remember, we decide if something is a function if the x value is not repeating. So we're always looking at the x values, right? So when I look at the first one, the only thing I'm looking at here is my x's. My y's don't matter. I'm only looking at my x's, and I'm seeing if any of the numbers repeat, right? None of these numbers repeat, so we would say, yes, it is a function, right? No repeats, it is a function. So if I look at number 10, I should not see any repeats here, right? But this 6 has 2 lines coming from it. 2 lines coming from it means that 6 is used twice. So there is a repeat in the 6, so this is not a function. And our next one, again, we're looking at the x values only. The y has nothing to do with it. I'm only looking at the x. There are no repeats in the x, so I would say, yes, this is a function. On my next one, a graph, I'm using a vertical line, right? You can imagine as many vertical lines. Imagine a ruler going across here. So even though here it's only touching once, if I can find anywhere that it touches more than once when I'm drawing a vertical line, then we say, no, it's not a function. Okay, on our next one, one line, one line, one line, one line. Those all have one line, so we would say, yes, this is a function. Okay, then we have another graph. Again, imagine a vertical line, so it's only touching once, 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 right? All of those times it only touches once. So we would say, yes, this is a function. Okay, number 11, the function f is defined by, okay, so we have f of x equals 1 over 6x, and it wants us to evaluate, find the value when x equals 3. So this says plug in x is 3. So we want 1 over 6 times 3, which is 1 over 18, which is going to be option D. Okay, on our last one here, we're going to graph this. Right, this is already solved for y, so we're just going to pick some values to plug in for x. Right, you do not have to pick -1, 0, and 1. I just suggested those as good values. So we'll say 3 times -1 minus 7, which will be -10. Right, then I'm going to plug 0 in for x. So I'll say 3 times 0 minus 7, which will be -7. I'll say 3 times 1 minus 7, which will be -4. So I'm going to plot the point, -1, -10, 0, -7, 1, -4, and there is my line.